I'm Katie Steckles.
And I'm Peter Rowlett. And Katie, what's our mathematical object for today?
So today's mathematical object is a deck of set cards, which is a specific thing. I'm not just saying a set deck of cards, but it is a game called Set. It's published by a company called Set Enterprises, one of those companies that was set up specifically to publish a thing.
Right.
And it's a really nice, simple game that has a lovely underlying mathematical structure. And it's one of those games which, even though there's all this maths behind it, anyone can play it. And quite often I find people who are not mathematical get on just as well, if not better, with it than maths people. So it's essentially...
I'm now wondering how you're going to explain all the cards to people that you can't see them.
If you can imagine using your imaginations. So the deck is made up of cards which have essentially 4 different properties. So on each card there are symbols. There can either be 1, 2 or 3 symbols on a card. So, each of the cards is one of those things. There can be 3 different colours. So some of the cards are red, some of them are green, some of them are purple. And within each card, the colour is always the same across all the symbols. The symbols can be 3 different shapes. So they can be a diamond shape, a sort of rounded rectangle, kind of ovally shape, and a squiggle. I think that's the generally accepted term.
Precise mathematical definition, yep.
And shapes can all be one of 3, I guess, textures might be the right word. So they can be a filled in, a hollow shape, or a stripy.
Okay. So you would have a card that's a single red diamond sort of dotted pattern. Yeah.
Like for each one, you can pick one of those 3 options, and they have to have picked one of those 3 options for each of the 4 properties. So that means that you can work out what all the possible cards might be, and within the deck there is exactly one of each possibility. So that's kind of the structure of it. And I guess before I go into how the actual game works, that in itself is quite an interesting structure, because you end up with, if you take away one of the properties, like if you say, okay, I'm only going to look at the solid coloured cards, then you get like a subset, I guess, a subset of set, which still has all of the other properties as a full range. So you can kind of picture like a 3x3 square. I guess if you slice out 2 of the properties, you end up with 2 properties that are still degrees of freedom. Right. So you could have a 3x3 square on the table where all the cards are green and all the cards are solid, but in each row they all have the same number, and in each column they all have the same shape. Right. So you could have like a kind of a magic square, a Latin square, I guess, of cards. And then if you wanted to add in more properties, you could maybe add in the different textures. So they're still all green, but you have a layer of that which is all the solid ones, and a layer on top of that which is all the stripy ones, and a layer on top of that which is all the empty ones.
So now I've got a cube of set cards.
You've got a cube of set cards.
Right.
And then if you're capable of existing in the 4th dimension, you could extend that again and have the same thing going off in 4D, but with the 3 different colours, I guess. Or you can have 3 separate cubes. Fine, that's the boring way of doing it. But all the red ones and all the purple ones as well. So
this the boring this universe's way of doing it.
Right. So this game has this really elegant structure to it, that all of these things exist exactly once each. And the thing about the game that's interesting is the definition of what a set is. So the definition of a set, this is a thing that sometimes takes people a couple of goes to actually get what it's saying. But
it sounds complicated, but once you played it a little bit, it's not.
Yeah, you kind of see what it means. So a set of 3 cards is a set in the game if for each of the 4 properties the cards are all the same or all different. And that's the technical definition, but to understand what that means, you kind of need to see a few examples. So I guess because there are 4 properties, each of them can either be the same or different. So the obvious, stupid, trivial example is that all 4 properties are the same for all 3 cards. And this doesn't actually work as a set, because if they're all the same colour and they're all the same shape and they're all the same number and they're all the same pattern, they're all the same card. And there aren't 3 of the same card. Yeah. So you kind of have to make one of them be doing different. So you could say 3 same, 1 different. So you could have, they're all the same colour, they're all the same shape, they're all the same pattern, but they're all different numbers. And in that case, you'd have for example, 1 green filled-in diamond, 2 green filled-in diamonds, 3 green filled-in diamonds, and that's a set. And that kind of set where you've got one property that's different and all the others are the same are quite nice and easy to spot because they look sort of obvious, and we kind of think of those as like a level 1 set. Like that's the
and so sort of 1 filled-in green diamond, 2 filled-in green diamonds, and then 3 filled-in green wiggles would not be a set because one of them isn't
so
the same or different.
The crucial thing is that they have to all be the same or all be different. And the big clue for if you've got something that's not a set is if you can say those 2 cards share a property that third one doesn't, then it's definitely not a set. If you've got 2 of something and 1 of another, then it's not a set. So it's got to either be 3 different or 3 the same, but for each of those 4 properties. So your level 1 set is one of the things differs, but you can go for a level 2 set where 2 of the properties are the same and 2 of them are different, and this is slightly harder again to see, but you could say, for instance, have 1 solid green diamond, 2 stripy green diamonds, 3 hollow green diamonds. And that's kind of, again, visually kind of looks kind of setish, and you can sort of see why it's a set. But it's kind of a slightly further level. And then, of course, the next level would be 3 properties different, which is, again... okay, I'll do an example. Oh, God. So 1 stripy green diamond, 2 empty red diamonds, 3 filled-in purple diamonds. Okay. Yes. So each card you need to specify 4 things, and it's just which ones are the same and different. And there are, of course, the horrible everything different sets, which don't look quite as setty, but once you get used to seeing them, you kind of figure that they're a set. So the way that the game is played is conventionally you will deal out maybe 12 cards onto the table, and people who are observing the 12 cards laid out on the table can look at them and try and find a set. And I think the best way, in order to avoid actual clawing of hands and grabbing at the same time, you can say politely the word set, or shout it in an extravagant manner if you so wish, if you've seen one, and you then have to point at the 3 cards that you think are a set. And if you're correct, you get to keep those 3 cards. And I think the classic way that I've played it is, if you're wrong, you give back one of the cards that you've previously won, and that goes back into the pile to be dealt out. Right. Which means it's kind of a sort of slight penalty for just saying set all the time, to discourage that. But I think when people are starting out, it's probably mean to do that. So you can relax that rule if you're just a beginner player.
You can also... I've played it with someone where you can play it as a sort of turn-based thing. If you've got a real disparity, you can say, you try and find a set for a minute and then I'll try and... or something like that. So, because some people are super good at this.
Yeah, I think if you've got a room full of people, one of whom is quite good at set, it does get pretty depressing for everyone else in the room. But I think generally it doesn't take long to get up to a sort of reasonable level, and... even if you're quite good at it, it's still occasionally you're just like, I can't see it, where is it? And some of them are more difficult to find than others. So if there aren't any really nice, obvious ones there, everyone is just staring at it for a couple of minutes. And then when someone's taken a set, you replace those 3 cards and you carry on. And if everyone in the room agrees that there isn't a set in the 12 cards that are on the table, you can add an extra row of 3 in order to give that possibility.
So now you've got 15. You don't take 3 away.
You just keep those down, and then the next set that gets taken takes you back down to 12. It's an interesting question, actually. If you've got 12 cards on the table, it is possible to have 12 cards without a set. And then you can ask yourself the question, what's the minimum number of cards you need in order to guarantee that there definitely is a set in there? And I'll leave that as an exercise, because that's quite a nice thing to try and figure out. There's a lot of these other nice little puzzles, because one of the intriguing things about the structure of set that I think is quite a nice observation is that the way it works is that for any 2 cards that you pick out, there is a unique 3rd card that makes a set. And that's also quite a nice way to learn about sets, is if you say to someone, if I had 1 empty green diamond and 2 empty green diamonds, what would the 3rd card be? Obviously it would be 3 empty green diamonds, but if you've got a more complicated one than that, you can deal out any 2 random cards and say, okay, what is the 3rd card for this set? And that kind of, I think, helps to sort of see how the whole thing sits together.
As soon as you start talking about it, I'm straight away thinking, how many cards are there and how many possible sets are there? These seem like quite nice counting questions.
Yeah, and the nice thing is that if you start playing with a deck of cards, I think this is true, it will always decompose into sets. Exactly, I think. Like if you take away all but 3 of the cards and put them in sets,
right?
Will the 3 remaining cards definitely be a set? And I think they do.
Okay.
Does that sound right? There must be. It must be true.
Okay.
Again, exercise.
So the
for
end
the
of the
reader.
game is that everybody has a pile of. They're collecting 3 cards at a time, right? So they're collecting sets. Assuming that either you don't have the rule of putting one back, or nobody's ever shouted the wrong thing. Everybody ends up with piles of 3 cards, and all the cards are used up.
Yeah, I think so.
Okay.
I might be wrong, but I don't know. But because there are some nice, interesting puzzles you can do about this. Because if you know, so there's a puzzle that was in one of the Maths Jam puzzle sheets a little while ago. So, people are doing this in the pub. If you had there was like a layout of maybe 10 set cards, one of which was face down, and you could see what these 9 cards were. I guess it will have been a multiple of 3, so it might have been 9 cards with 1 face down. And they said, this is the end of a game of set.
Right.
What's the face down card?
Okay.
And it's quite a nice little puzzle because...
So you have to find 2 sets and then find the card that would make the remaining 2 cards into a set.
I think I'm now wondering if it isn't always the case that you get sets, because essentially what you had to do was look at it and say, okay, everything that's been taken already was a set. So for each set that's been taken, you either took, say for instance, 3 green ones, or 1 red, 1 purple, 1 green. So the number of greens that are left at the end is going to either be, it's going to be like a multiple of 3, or it's going to have the same number of reds and purples taken away as well. Okay. And you could use that to try and determine the colour of the remaining card, and then obviously you can repeat the same exercise for each of the other 3 properties. So that it's not just a game; it's also got this sort of element of puzzle to it as well. And I think it's really nice because it's about pattern recognition. And even if you're not a mathematician, this is one of those sort of human traits that it's known that people are very good at, or evolutionarily there are pressures towards it because it's a good time-saving shortcut and it allows you to recognise predators easily and this, that and the other. And it kind of hones those skills. It kind of develops your pattern recognition. And it's also just quite fun, I think. There are probably other games that you can play with the same set of cards as well. So, I like the making a set magic square is good. Like you can kind of grab a few cards to start you off and put them in random places, and then say, okay, how can I finish this so that every row and column and diagonal of this square is a set? And we did this in the pub once. Actually, we made a 3x3 set magic square, and then someone was like, well, can we do a magic cube where every row, column, and diagonal and whatever the other ones are called of a cube is also a set? And we did that. And we had these kind of laid out on the table as 3 grids or whatever. And someone came over and went, I can see a set. We're like, yes, yes, everything is like all the rows and columns are a set. Well done. Yes,
we aren't currently playing set, we're just playing with set.
But yeah, it's this classic thing that you tweet a picture of what you're doing at Maths Jam and you tweet a picture of the table with a game of set in progress and everyone replies and says set. Because they can see what you're doing. But yeah, we did this, and I think we then carried on and did the 4D one, so like a 3x3 grid of 3x3 grids, filling this entire table in the pub, and people walking past asking what the hell we're doing. But we had, we managed to lay them all out like this. So that's telling me maybe you can always I'm going to prove that later. That's my job for this afternoon, I think. But yeah, so it's. Online version is available. I think there have been various apps. There was an official set game app, which I'm not sure if it's available anymore, but there are various knockoff versions that you can find. And I think some of the people that do really well at it at Maths Jam are people who've got the app and play it on the bus when they're bored, because it really hones you. You suddenly become really good at it, having played a bunch of the online version. Yeah,
I'm remembering seeing a tweet a while ago where Ben Nuttall had made set in Pygame in the Python extension for making it. I imagine that programming a game that plays set is probably a really good way to get good at it.
It's quite a fun thing to put together. Yeah, I've also, because I've subsequently stolen Ben Nuttall's version and converted it. I've reskinned it essentially, so now I have a NES version of set, which I've put on a Raspberry Pi for my husband. But it's kind of it's the chunky graphics version of it, but it was also nice to sort of see under the hood and see how it plays. And I've done some minor tweaks to the gameplay and the way that the thing works. but it's such a simple structure. Once you can comprehend the sort of rule, and it's got a lot of fun.
Good. Right, so I'm on Twitter as @PeterRowlett.
I'm @Steckles on Twitter.
And we both blog at a site called aperiodical.com, and that's where you can find more episodes of this podcast.
And if you want to get in touch, if you have worked out the answer to the thing that I didn't know the answer to, or any other things that I don't know the answer to, that's most things, or if you want to suggest an object that we could talk about in a future episode, you can email objects@aperiodical.com.
The music is Funk Game Loop by Kevin MacLeod, licensed under Creative Commons.